Assalamualaikum everyone and a very good day to all. So I shall continue with defining networks. What are the criteria that define a network? What are the structures? And also what are the different types of networks? Here is the table of contents for you to navigate through this video. These are the learning objectives to be obtained after you went through this video. You can check them yourself whether you have acquired the objectives or not. So what is a network? Network is a set of devices or nodes connected by communication links. A node can be a computer, printer, or any other device capable of sending and or receiving data generated by other nodes on the network. In other words, a network consists of two or more computers that are linked so they can share data or resources, so they can exchange files or allow communications. The computers on a network may be linked through different mediums such as cables, telephone lines, radio waves, satellites, or infrared light beams. So we will look at the network in depth by looking into these criteria or characteristic of a network. And they are distributed processing, network criteria, physical structures, and network types. I hope you understand what is a network. If you don't, then here is another definition of it. And most of these network, they used distributed processing. What is distributed processing? It is when a task is divided among multiple devices where each devices will handle a subset as opposed to the whole process on its own. So it is important in the case of, you can imagine it like we are delegating the task or the job instead of one person doing it all, because it is just not feasible. Next, we go to the network criteria. So a network must be able to meet a certain number of criteria, and these three are the most important ones, and they are performance, reliability, and security. What does it mean by performance? Performance means that we have to measure the performance. There are many matrices out there. There are many assessment methods or parameters that we can see whether it performed well or not, and one of them is transit time and response time. All right, so what is transit time? Transit time is the time a message takes to travel from a source to a destination. So it means that we want to know how long does it take for the message to travel from the sender to the receiver. And the response time is basically is the time between the end of a query to a computer system and the beginning of a response. So in other words, response time is the total amount of time it takes to respond to a request for a service. And then the reliability means that we need to have a reliable system or communication system. This can be measured by the frequency of failure. If it's always failure and the rate of the failure is too high, that means that it is not reliable. And it also can be measured by looking at the time it takes a link to recover from a failure, because there will be some failure due to the collision of data, and that will show the network's robustness or scalability of any catastrophe or any failure of the devices. Next, we go to security. Security, as the name already shown, it requires security where nobody outside of the network can do any damages or unauthorized access, or this is to secure the data from any hackers, or if you know your data has been changed by unknown or unauthorized people. When we talk about a network, it means that there will be two or more devices connected through links. And these links must be connected in some way to the same link at the same time. There are two possible types of connections, point-to-point or multi-point. A point-to-point connection provides a dedicated link between two devices, and the entire capacity of the link is reserved for transmission between those two devices. Okay, most point-to-point connection, that usually use the actual length of the wire or cable to connect the two ends, but there are also other options, wireless options such as microwave or satellite links, or even when we change the television channels using infrared remote control, then we are establishing a point-to-point connection between the remote control and the television's control system. Then we have a multi-point. Multi-point, also sometimes called as multi-drop, is a connection where where more than two specific devices shares a single link. In a multi-point environment, the capacity of the channel is shared either spatially or temporally. When I mention spatially, it means in terms of space, and when I mention temporally, it means in terms of time. That means that there are also like specially shared connection. That means that the devices use the link simultaneously at the same time. And there is also time shared connection, where it means that there are other users or the devices must take turns to use the link. So the other physical structures of a network is physical topology. Physical topology is the physical layout of nodes on a network. It means that two or more devices connect to a link, and two or more links form a topology. So the topology of a network is the geometric representation of all the links and linking devices, or sometimes we call it as nodes, to one another. Okay, so we can have four basic topologies. We can have a mesh, star, ring, and bus. And any combination of this topology is called hybrid. Another way of saying this, in the context of a communication network, the term topology refers to the way in which the endpoints or stations attached to the network are interconnected. The choice of topology depends on a variety of factors, including reliability, expandability, and performance. This choice is part of the overall task of designing a network, and thus cannot be made in isolation. It needs to depend on the choice of transmission medium, the wiring layout, and also the access control technique. The mesh topology incorporates a unique network design in which each computer on the network connects to every other computer or devices, creating a point-to-point connection between each and every device on the network. The purpose of the mesh design is to provide a high level of redundancy. If one network cable fails, the data always has an alternative path to get to its destination. In this figure, it shows the mesh topology. If, for example, we have n number of devices connected with each other in mesh topology, then the total number of ports that is required by each device is n minus 1. For example, in this case, there are 5 devices connected to each other, hence total number of ports required is 4, meaning that for each devices there are 4 different devices or they to be connected, so they need 4 ports for this connection. If, for example, there are n number of devices are connected with each other in mesh topology, then the total number of dedicated links or cable required to connect them is n multiplied with, in a bracket, n minus 1, and then divided by 2. In this figure, we can see there are 5 devices connected to each other, so the total number of links required would be 10. So these are the advantages for mesh topology since they have dedicated links between any two devices, so they can manage high amount of traffic because multiple devices can transmit data simultaneously. As I mentioned just now, it also provides redundant path between devices, so a failure of one device does not cause a break or total failure in the network or transmission of data. And the network can also be expanded without disruption to current users, meaning that it is scalable and easy to extend. However, as you can see, the wiring for a mesh network can be quite complicated. Therefore, the cabling costs associated with mesh topology can be high, and troubleshooting a failed cable can be tricky as well. Because of this, the mesh topology is rarely used. A variation on a true mesh topology is the hybrid mesh. It creates a redundant point-to-point network connection between only specific network devices. The hybrid mesh is most often seen in WAN implementations, and I will show you later what is WAN or WAN. And again, with the dedicated links, it requires more cable, and with that redundancy, it also adds on to the high cost, and also there is potential for reduced efficiency when the links are not used. As for the installation and configuration and also the implementation, it is quite complex and quite difficult. Again, with the cost, it is costly, meaning that it is more expensive in order to maintain and also to implement if compared to other network topologies. In the star topology, all computers and other network devices connect to a central device called a hub or switch. Each connected device requires a single cable to be connected to the hub, creating a point-to-point connection between the device and the hub. So that means that each device requires only one port, i.e. to connect to the hub. And there can also be where each station attached to a central node via two point-to-point links, one for transmission and one for reception. But unlike mesh topology, a star topology does not allow direct traffic between devices because the devices are not directly linked to one another. And the N devices, like for example, if you have N devices are connected to each other in the star topology, number of cables required to connect them is N. Some would say N minus 1 because they would consider the central hub switch is also N. So it depends on how you look at it. So make sure that you understand this correctly. If it's the central hub is not included, that means that the number of cable is N. But if you want to include the central hub within the calculation, the number of devices, then the number of cable has to be N minus 1. Okay. In general, there are two alternatives for the operation. One approach is that the central node to operate in a broadcast fashion, broadcast meaning that it will send exactly the same message to all of the devices, and a transmission of a frame from one station to the node is retransmitted on all of the outgoing links. Okay, so in this case, the broadcast fashion, although the arrangement is physically a star, it is logically a bus because it is transferring to all at the same time, the same message or the same data. And a transmission from any station is received by all other stations, and only one station at a time may successfully transmit. In this case, the central element is referred to as a hub. Okay. Another approach is when we want to use it as a switching device. Okay, so the central node, when the central node is a switch, then that means that an incoming frame is buffered in the node and then retransmitted on an outgoing link to the destination station on its own. It's not broadcasting if it's a switch. If it's a hub, that means that it is broadcast all the message to all the same devices. Using a separate cable to connect to the hub allows the network to be expanded without disruption to the network. A break in any single cable will not cause the entire network to fail, meaning the rest of the network continues to function normally. And the star topology is the most widely implemented network design in use today because it is also easy to set up and to troubleshoot and isolate problems or fault. Because all devices connect to a centralized hub, this creates a single point of failure for the network. If the hub fails, any device connected to it will not be able to access the network. Because of the number of cables required and the need for network devices, the cost of a star network is often higher than other topologies, and it is also more difficult to implement compared to other topologies as well. The performance of this network will be based on that single concentrator, i.e. the hub or the switch. In the ring topology, the network consists of a set of repeaters. They're joined by point-to-point links in a closed loop. The repeater is a comparatively simple device. It's capable of receiving data on one link and transmitting them bit by bit on the other link as fast as they are received. The links are unidirectional, that is, data transmitted in one direction only, so that data circulates around the ring in one direction, either clockwise or counterclockwise. As you can see in this particular figure, it is clockwise. But it can actually be made into bidirectional by having two connections between each network node. But then it will be called a dual ring topology. Each station attached to the network at a repeater and can transmit data onto the network through the repeater. Okay. To transmit the data, station has to hold the token. After the transmission is done, the token is to be released for other station to use. When no station is transmitting the data, then the token will circulate in the ring. Let's see an example. See here, C is transmitting a frame and it addressing to device A. So the frame will circulate past all the other station. For example, here it will pass by device B. Frame is not addressed to B, so B ignores it, and it will go by device A. So here A copies frame as it goes by. As this is when the destination station recognizes its address. So it will copy the frame into a local buffer and then it will go by. And the frame continues to circulate until it returns to the source station, which is in this case C, where it will remove, where the token will be removed. Okay, so because multiple stations shares the ring, medium access control will be needed. That's why there will be a token release, and also there will be a station that is monitoring all this process as well, which we will learn later on, inshallah. This medium access control is basically to determine at what time each station may insert frames. These are the advantages of ring topology, as all data flows in one direction, so there will be less chance of packet collisions. It is easy to install and expand, and data can transfer between workstations at a very high speed. Also, a network server would not be needed to control the network connectivity between each workstation. And the disadvantages, all data being transferred over the network must pass through each workstation on the network. So somehow it will be slower, even though it's supposed to be fast, but it will be slower than a star topology due to the many devices to pass by. The entire network will be impacted if one workstation shuts down. So this is very crucial. And the hardware needed to connect each workstation to the network is more expensive than Ethernet cards and hubs or switches. And also the troubleshooting is difficult in this topology because once one is failed, then the whole network will be failed, and it's kind of difficult to find out where exactly is the source. Also, if you remove or add stations in between the stations, it can disturb the whole topology. Actually, in the past, the ring topology was most commonly used in schools, offices, and smaller buildings where networks are smaller. However, today the ring topology is seldom used because there are many other type of network topology that is better in terms of performance, stability, as well as support. Next, let's go to bus topology. Bus topology is a multi-point connection. Before this, we only talk about topology with point-to-point connection. So in bus topology, there is one long cable acts as a backbone to link all the devices in the network. So that means that in terms of cabling, even if you have n numbers that connected in the bus topology, the number of cables required to connect them is 1. And it is known as the backbone cable. But you would still need n drop lines as required. You might also have heard about tree topology. Actually, the bus is a special case of the tree topology, where bus topology has only one trunk and no branches, and the tree has branches. Both bus and tree topologies are characterized by the use of a multi-point medium. For the bus, all stations attach through appropriate hardware interfacing known as a tap directly to a linear transmission medium or bus. Nodes are connected to the bus cable by drop lines and taps. A drop line is a connection running between the device and the main cable or the backbone cable. A tap is a connector that either splices into the main cable or punches the sheathing of a cable to create a contact with the metallic core. Okay, so as the signal travels along the backbone cable, some of its energy is transformed into heat, therefore it becomes weaker and weaker as it travels farther. For this reason, there is a limit on the number of taps a bus can support and on the distance between those taps. Okay. The tree topology is again a generalization of the bus topology, the transmission medium in a branching cable with no closed loop. The tree layout begins at a point known as the hidden. Okay, and one or more cables start at the hidden, and each of these may have branches. The branches in turn may have additional branches and so on. So there will be quite a complex layout. Again, a transmission from any station propagates throughout the medium and can be received by all other stations. Let's see how it works. In this example, we have station C wishes to transmit a frame of data to A. The frame header includes A address. As the frame propagates along the bus, it passes B. B observes the address and ignores the frame. A, on the other hand, sees that the frame is addressed to itself and therefore copies the data from the frame as it goes by. The advantages of bus topology: it works well when you have a small network because it is easy to install and therefore it requires less cable length than a star topology, and due to that also the cost of the cable will be less. The disadvantages: it can be difficult to identify the problems if the whole network goes down. If the common cable fails, then the whole system will crash down. If the network traffic is heavy, it increases collision in the network. So that's why bus topology is not great for large networks. And if you have too much devices, it will slow down the network. And sometimes if the main cable is damaged, the network fails or split into two. A hybrid topology is a type of network topology that uses two or more different network topologies. The choice to use the hybrid topology over a standard topology depends on the needs of a business or the users, the number of computers, their location, and desired network performance. All of these factors has to be made into decision making. And the two most commonly used of hybrid topologies are star ring topology which is a combination of a star topology and ring topology, and also a star bus hybrid topology, which is a combination of the star topology and bus topology. So two or more star topologies are connected through a bus topology. Next, let's discuss the different types of networks we encounter in the world today. The criteria of distinguishing one type of network from another is difficult and sometimes confusing. So we use a few criteria such as size, geographical coverage, and ownership to make this distinction. The network allows computers to connect and communicate with different computers via any medium. LAN, MAN, and WAN are the three major types of the network designed to operate over the area they cover. There are some similarities and dissimilarities between them. One of the major differences is the geographical area they cover. For example, LAN covers the smallest area like a building, an office. MAN covers an area larger than LAN, such as cities, states, and WAN comprises the largest of all. It can be even number of cities or countries, or even the whole world. There are other types of computer networks such as PAN, which is personal area network. We have storage area network. We have enterprise private network, virtual private network. But in this course, we will just discuss on these three types of network. LAN stands for local area networks. It is a group of network devices which allow the communication between connected devices. It is most typically, it is a private ownership. Okay, private ownership that has the control over the local area network rather than a public. LAN has short propagation delay than MAN as well as WAN, and it covers the smallest area as I mentioned just now. One MAN or metropolitan area network covers a larger area than LAN and a smaller area as compared to wide area network. So it connects two or more computers that are apart but resides in the same or different cities. It covers a large geographical area and may serve as internet service provider. MAN is designed for customers who need high-speed connectivity. Okay, for WAN or wide area network, it is a large area than LAN as well as MAN, such as it can cover the whole country or continent, and one is more expensive and should or might not be owned by one organization. Okay, there are many advantages of LAN over MAN and WAN. Okay, such as LAN or local area network provide excellent reliability, high data transmission rate. It can easily be managed and shares peripheral devices too. But local area network cannot cover cities or towns, and for that MAN and WAN is needed, which they can connect cities, or group of cities, and countries and so on. With that, I would like to end this chapter 1. So we will see in chapter 2, inshallah. Before I end this video, please let me know how is your understanding on this topic throughout this video so far at this link. Your participation is highly appreciated. If you have any questions or comments, please let me know. Thank you and see you on the next video.